So let's talk about something that's fundamentally changing how software gets made. I mean, this is probably the biggest shift we've seen since we moved to high-level languages. We're going from a world where we write code line by line to one where we just orchestrate an idea. And this whole revolution, it has a name: vibe coding.
And this quote right here, which totally blew up in the tech world in early 2025, just nails it. All of a sudden, the biggest hurdle to creating software isn't about mastering some arcane syntax anymore. No, it's about how clearly you can explain your vision to an AI.
Okay, so here's the game plan for this explainer. First, we're going to unpack what this vibe coding thing really is. Then, we'll introduce you to the new AI teammates that are making it all happen. After that, we'll get into the nitty-gritty of the professional discipline you need to do this right, weigh the massive promise against the very real peril, and finally, we'll try to sketch out what the developer of tomorrow is actually going to look like.
All right, first up, what exactly is vibe coding? Let's get past the buzzword and figure out what we're really talking about here.
This term is actually popularized by the legendary AI researcher Andrej Karpathy. And his whole vision was a new kind of workflow where your main job, as the developer, is to focus on the outcome you want, the vibe, while you let a large language model handle all the boring line-by-line grunt work.
And this slide, this really gets to the core of it all. It's a total flip. I mean, for decades, a developer's job was to painstakingly translate human ideas into the rigid logic a machine could understand. Now the job is to just state the idea clearly and then be the final boss, the quality check on what the machine spits out. We're shifting from being code writers to being system architects.
And that brings us to the central tension in this whole thing. You've got the YOLO approach, right? Just telling the AI to do something and blindly accepting the result. That's fine for a hackathon project, but for real, professional, enterprise software, you need discipline. And that is the difference between vibe coding in the wild and a tamed professional workflow.
So how are people actually doing this stuff? Let's take a look at the tools that are making this a reality. And just to be clear, we're not talking about fancy autocomplete here. We're talking about full-blown AI-native coding environments.
The two big players in this new space are Cursor and Windsurf. Now, they're both built on top of VS Code, which is familiar, but they have completely different philosophies. Think of it like this. Cursor is like a hyper-advanced tool for an architect who gives very precise top-down commands. Windsurf, on the other hand, is more like a collaborative teammate you can literally have a conversation with. This table really breaks down those differences. Just look at the core interaction row. Cursor's composer is built for making these big, sweeping changes across many files. But then you look down at context, and you see you often have to manually tell it which files to look at. Windsurf's Cascade is totally different. It's designed to figure out the context on its own. And even crazier, as you see in error resolution, it'll even try to auto-fix its own mistakes. But you gotta remember, the editor, the IDE, that's just the interface. The real horsepower comes from the large language model running underneath. And right now, in 2025, Claude 3.5 Sonnet is pretty much the gold standard. Why? Mostly because it has this massive context window, meaning it can remember what's in dozens of files at the same time, which is absolutely crucial for understanding a complex project.
Okay, so you've got these ridiculously powerful tools, but how do you use them to build something solid without creating a tangled, unmaintainable mess? Well, that's where having a disciplined, professional workflow becomes absolutely essential.
The professional, what we're calling the tamed approach, really boils down to these three phases. First, you start with a super detailed spec, no room for confusion. Then you prime the AI, basically teaching it the rules of your specific project. And only then do you jump into what's called the vibe loop, a super fast cycle of prompting, generating, and this is the most important part, reviewing the code.
Let's zoom in on that first step, because it's so important. Before a single prompt is written, you create a spec file. This is your Bible. It defines what the user is supposed to do, the exact data structures, the tech you're using, and how you're going to prove that it works. Adi Usmani has this great phrase for it: waterfall in 15 minutes. It's this short but absolutely critical planning phase that saves you from a world of hurt later.
And this right here, this might be the single most important rule in this entire workflow. You have to treat the AI like a brilliant, super fast, but very inexperienced junior developer. It's talented, but it will make mistakes, guaranteed. Your job is to be the senior engineer in the room, the one doing that critical code review. Whatever you do, never ever just click accept all. Now, all this speed and all this power, it doesn't come for free. It brings its own unique set of dangers. And honestly, knowing how to handle these risks is what's going to separate the professionals from the hobbyists in this new AI era.
The number one risk is something called vibe collapse. This is what happens when code gets generated so fast that you, the developer, lose the mental map of how your own system works. The codebase becomes this fragile, brittle thing where any tiny change can cause the whole house of cards to fall down. You've basically lost control of your own software.
But here's the crucial part. These risks are totally manageable. To stop that vibe collapse, you commit tiny, isolated changes. If something breaks, you git revert immediately. For security, you can literally prompt the AI to act like a security expert and double-check its own work. And for privacy, the rule is simple and absolute. Do not ever paste sensitive company secrets or customer data into that prompt window, period.
Now check this out because it's a fascinating paradox. A recent study from Mitra found that for really experienced developers working on hard problems, these AI tools actually slowed them down by almost 20%. What? Why? They call it the review tax. It's the extra time you have to spend hunting for really subtle, tricky bugs in the code the AI wrote. It's a huge reminder that you have to know when to use the tool and when to just write the code yourself. So, given all of this, the new tools, the new workflows, the new risks, what does this all mean for the future of the software engineering profession itself?
Well, for starters, the way we measure what a good developer even is has to completely change. Old school metrics like lines of code, totally meaningless now. The new metrics are all about outcomes. How fast can you get from an idea to production? How often does your code have to be reverted? And maybe the most important one, how good, how deep is your code review?
And that means the skills that are most valuable are shifting too. Simply memorizing syntax is way less important. What's absolutely essential now is high-level system design, seeing the whole board, understanding how all the pieces connect. It's having a ruthless discipline for testing. And, of course, it's the ability to communicate with absolute clarity in your prompt.
Which brings us to one last, kind of provocative thought. If the human's role is shifting from writer to architect, from the one doing the work to the one reviewing the work, does that mean that the best coders of the future might not actually write much code at all? Their true value will come from their vision, their high standards, and their ability to orchestrate these AI agents to make that vision a reality. It's a massive shift, and it's not coming. It's happening right now.